This video is going to look at questions 41 through 45 on the 2011 June Regents exam. So let's get started. 41 is asking about the graph that represents the relationship between gravitational force and distance away from the Earth. And this very straightforward question. If you get farther away from the Earth, the gravitational force should decrease. That force also never actually goes to zero. All right, well, if it's decreasing, that is out and that is out. So we're down to 2 or 3. Your force is not going to ever hit zero, okay? So this is a problem. So that's no good. This is your inverse relationship graph right here. All right, easy question. Here's another graph. This is looking at GPE versus height. All right. Well, as you get higher, GPE should increase. So that's out and that's out. So these two and 3, both have gravitational potential energy increasing as height increases. And if you look at your GPE formula, you have GPE equals mgh. There's nothing squared. There's no reason for this graph to be curved. That is a nice linear relationship right there. For 43, this has a ton of words and does not need to be complicated. All right, again, ultimately it's asking to find the graph that represents the relationship between the magnitude of force on a charged particle versus electric field strength. Okay, so we're looking for a relationship between force versus electric field. And if you remember, electric field equals force over charge. So if you increase force, you will, or if you increase field, you will increase force. All right, the stronger your field, the stronger your force. There is nothing squared in this, so we are looking at this guy right here. Number 44. This can be a tricky question if you're not careful. Right, this is a series circuit right here with 2 resistors, and it's asking us to find the current through the 20 ohm resistor. All right, beware of these types of questions because people's first instinct is to say, okay, well, I know how to do this. I know that I equals V over R. That's 20 over 120. And I'm sorry, 120 over 20. And so that should be 6 amps. All right, that is wrong because the voltage here is not 120 volts. Okay, that is the wrong way to do this. If we want the current here, we need to take the total resistance into account. Okay, and remember that the current is the same everywhere in a series circuit, but that current has to go through both resistors. All right, so the total. All right, we can set this up the same way, but your resistance is not 20. All right, the total resistance is going to be 30, and so this is actually 4 amps. All right, remember in a series circuit, that 120 splits up. All right, so you don't have all of it on this. Okay, you're only going to have 80 volts actually on the 20. It'll be 80 volts on the 20 and 40 volts on the 10. And lastly, number 45. This is a very straightforward magnet question. All right, just remember, for your magnetic field lines, they go out of north and into south. So it looks like they're going out of A and into B. That means that A is your north and B is your south. Check.